Good morning, my dear students. Today we'll see linear bounded automata visualization, how it is working. We'll consider a language of A power n, B power n. So I'll take left hand marker. You all know there will be a two markers between the input symbol. So it is, I'll consider as WA, WB. So I'll load the machine with that particular thing. So let the initial state be Q naught. So I'm constructing the table transitions. So when it is Q naught, when it is the initial symbol, I'm just moving right. I'm start reading my first A symbol. So when I started reading my A, I'm making that A to be changed as X and I'm moving to right and my state is changed to Q1. So next step is A, Q. So that is what it is happening over here. Okay, Q naught A, it is moving X writing and you are moving right. Next what we are doing is when it is going to be in Q1, when I am encountering A, I am not going to change anything. I'll change it to just I'll move right. That is what it is being done here. Now what I have to do is I have to match this A with the B which is there on the right hand inside. So you all know this is a language of A power and B power n. So I don't want to go to the end and come back. So whenever all A's are over, the first will be the character will be B's. So I have to equate the number of A's and number of B's. The structure is defined as A power number of A's followed by number of B's. So when it is encountered a B, I'll change to Y. B, it will be changed to Y and you will be moving left and you will change the state. So in this state changes, what it is being done in Q naught, whatever might be the A you are reading, we are just moving left. I'll just move left when it is X also. What happened is till that you have changed, you have equated your A's and B's. So now when it is encountered X, I'll start with the same state, Q naught. So next step it will move on to Q naught. The same cycle is being repeated. So A it will be changed to X. When it is changed to X, it is Q1. Q1 on Y, I'm just moving right. And Q1 on B, I'm just moving to Y. Coming left, Q naught, it is there. When it is X, Q naught it will be changed. When Q naught on Y, what happened in Q naught on Y? When it is Q naught on Y, I'm considering that as a final state. I'm not doing anything. You are going to stop the process. Okay. So this is what it is being done. So this is our diagrammatic representation for that. So now when you consider triple A and triple B, if you want to test it, we can have it. I load the machine. I'll have it. So we have the Turing machine diagram being represented. So it is changed. Q1 it is staying, moving is changed to Q2 and it is coming back and it is in Q2 just moving left and it is Q0, it will move to Q0, changing A to X and Y is just moving. I'm staying in the same state. When it is B, Y moves left, Q2 comes over here, changing to Q0, it goes on, Y it goes on, it goes on, it comes, okay, it goes to Q3, it stops there. Suppose if I am not taking any equal thing, I am loading it, we'll see the transitions. I will have matched 1A moving right, 1B change to Y, coming back, change to X, moving right, change to Y, coming back, change to X. Okay, it is not reaching that Q3 state. So Q3 is our final state. So your automata is not going to accept this particular machine. I hope you all understood this particular language A power n, B power n. Suppose if it is C power n, what we can do is the same we should write it. Let us consider. So what will happen is when it is Q0, I start reading the A, I change that to X, I move to Q1. When it is Y, I'm just moving Q1, when it is B, I'm changing it. Q2, what we have to write is, when it is Q2, what we have to write is, will remove it. When it is Q2, what we have to do, the init is going to be C. Okay? So when it is going to be C, we are going to write it as Z and then move left, go to a different state. Okay. So if it is first C, if suppose if it is second C, I might have got some C's, so I will just move left and stay in the same state. So this is what I did. When it is coming left in Q2, what and all I will encounter in Q2, when I am coming back, I will encounter B also. So when it is B also, I don't want to do anything. Just move left. When it is encountering B, and I can go for changing that state, indicating that I have gone to the next part. Okay, so I'll change to Q4. This indicates that I am made to. So when it is Q3 state, what happened is when it is in Q3, what we have done, we have changed one C to Z. Okay, when you are changing one C to the remaining C's, Z will be there. All this same will be repeated. When it is B also, we are going to write it in Q4. And in Q4, what we are going to do is, okay, when it is encountering coming back, there will be a Y. Don't do anything. Move left. Okay. Then there will be a. Okay. When it is coming back, there will be a. What you have to do is just move left. Okay. Then it will be an X. Then it is an X. Okay. Right. You're not doing anything. Move to right. Change the state to Q naught. This is how it will be done. Okay. So we can write it, load it. We have a state, sorry, this colon. We can just proceed it, and this will be changed to X, and it proceeds further. Okay, here we didn't change this actually. It should be right now. We'll load the machine. Right now. So we have to load it. When it is Q naught, you are changing it to right. When it is A, we are changing it to X and we are moving right. Q1 on A, you are moving right. Q2 on 2, it is moving right. Okay. Q2 on B, we have changed here as we don't want to do anything. We are just moving right. Okay. So we'll proceed. Change to. Then we'll change Z. Then we'll come back. Okay. When you are coming back on Z, it is Q4. So Q4 on Y, it is left, it is low, it is Y we have written. So we'll change to X, we'll proceed, come back, come back, come back, then the process will start. Y, Z. Okay, so in this state, if you see, we didn't do anything. So Q4, we didn't do anything. Q0, when it comes, X we are doing it. Y, B, we are changing it. C, when it comes here, we should write Z now. In Q2, you should not, you have to write. Okay, let's proceed X. I'm showing it such that you will try to write your own problems, whatever you want to solve it. Okay, with that we will stop the process. Okay, so we'll see the steps how it is being done in the LPA. So we have Q0, Q1, it goes on, Q2, Q3, Q4, and it repeats over there, and the same cycle is being repeated. Okay, so this is how it is being done for a linear bounded automata. Here the boundary is we don't have a blank space in our tape, and it is bounded by n markers. I hope you all understood, my dear students. Thank you.